Welcome dear student and Jai Swaminarayan. In the previous video, we will discuss about the carbon compounds, formation of the very large number of the carbon compounds, right? Carbon compounds makes a covalent bond with the other carbon atom, right? In a chain form, in a branch form, in a ring form, right? And makes a large number of the carbon compounds. In the previous video, we will discuss about the carbon atoms makes a covalent bond with the hydrogen atom. Single covalent bond, double covalent bond between the two carbon atoms and triple covalent bond between the two carbon atoms, right? And the name that alkane, alkene and alkyne. If there is a single bond between the carbon atoms, the group is called the alkane, right? It names with end with the ane, like a CH4. Carbon atom makes a covalent bond with the 4 hydrogen atom CH4. The name is a methane. Two carbon atoms makes a single covalent bond and the other valency of the carbon atom makes a covalent bond with the hydrogen atom, right? That is the molecular formula C2H6, that is the ethane, right? So these are the hydrocarbons, right? The carbon compounds makes a covalent bond with the hydrogen atom, that is called the hydrocarbon, right? Two types of the hydrocarbon, you know, saturated hydrocarbon and unsaturated hydrocarbon. Now the carbon atoms are makes a covalent bond with the other functional group like a chlorine atom, fluorine atom, bromine atom, right? Oxygen atom, nitrogen atom, right? So carbon atom makes a covalent bond with the other atoms that gives the property of the carbon compound is called the functional group, right? So in this video we will discuss how the carbon atom makes a covalent bond with the other atom, other functional group or atom or a group of the atom, right? And then after we again discuss the homogeneous series of the carbon compound, that is the alkane, alkene and alkyne, right? So let us start with the some functional group in the carbon atom. So what is the functional group? An atom or a group of the atom which decides the property of the carbon compound is called the functional group, right? So functional group is a group of an atom. It is a one type of the atom, like a single atom, like we consider as a chlorine, bromine, oxygen, nitrogen. That is the single atom, right? Which are a group of the atom. That means the group of atom, oxygen and hydrogen atom, carbon, hydrogen and oxygen atom, carbon and oxygen atom, right? So these are the group of the atoms which decides the property of the carbon compound is called the functional group. So dear student, in this video we will discuss the some functional group and how we can name their functional group, right? Like a haloalkane group, right? The formula of the functional group is a ClBr haloalkane group, that is a chlorine, bromine, iodine, right? That all the atoms makes a covalent bond with the carbon atom, that is called the haloalkane group and its name with the chloro, bromo, fluoro, right? So we consider the first functional group is a haloalkane group. Second heteroatom is the oxygen atom, and the oxygen atom or group of the oxygen atom with the other atom, like a first functional group in the oxygen atom is a alcohol. Its a formula ends with the OH, right? Aldehyde, its a formula ends with the CHO. Carbon and oxygen makes a covalent bond and carbon makes a single bond with the hydrogen. So its a formula ends with the CHO. Third functional group is a ketone, right? That is a CO, right? Its a formula end with the CO. Formula of the functional group is a CO. And fourth functional group is a carboxylic acid. It ends with the COOH. So dear student, in this video we will discuss one by one all the functional group and how the name of the all the chemical formula, name of the chemical formula, how we can write the name of the chemical formula of all the functional group, and what are the carbon compounds formed by this functional group, how the carbon compounds formed by this functional group, right? So let us start with the functional group, and each and every functional group we will detail. So what are the functional group? Dear student, this question is a very important for the examination purpose, and this question is very important for the 11-12 science chemistry, the basic concept of the 11-12 science chemistry. So what is the functional group? An atom or a group of atoms which decides the properties of the carbon compound is called the functional group, right? There are five types of the functional group as we had discussed earlier: halide group, or we can say that the halo group, alcohol group, aldehyde group, ketone group, and carboxylic acid group, right? So first functional group is a halo group. Halo group, the having a atom is a chlorine and bromine, right? It ends with the formula, molecular formula, chlorine, bromine, right, iodine, that all the things, right? It's the halo group name ends with the in, right? For example, simple hydrocarbons we take a CH4, right? Simple hydrocarbon we take a CH4, that is called the methane. So suppose here we consider the structure of the methane, that is a carbon compound makes a covalent bond with the 4 hydrogen compound, right? 4 hydrogen atom. So carbon atom makes a covalent bond with the 4 hydrogen atom like this. The the molecular formula of this structure is a CH4. That is the name is a methane. Now from this, if we consider that if the one hydrogen atom is removed from this formula, right? If one hydrogen atom, this hydrogen atom is removed this formula, and instead of this hydrogen atom, we place a chlorine or bromine atom, right? So instead of this hydrogen atom, we place a chlorine. What is the formula? CH3Cl, right? So the name of this carbon compound is a Cl formula. Its name is a chloro, and CH3, that is the one only one carbon atom, that is a methane. So the name of this formula is a chloromethane, right? Understand? Instead of this chlorine atom, if we take a bromine atom, right? Instead of this chlorine, instead of this hydrogen, we make a bromine atom. Its a name end with the bromomethane, right? Understand, dear student? So molecular formula CH3Br, that is the bromomethane. CH3Cl, that is the chloromethane. Similarly, you can make a molecular formula of all the hydrocarbon: methane, ethane, propane, butane, pentane, and hexane. You know all the molecular formula of all the hydrocarbons, right? Similarly, dear student, if you consider the ethane, right? Molecular formula of the ethane is a C2H6, right? So in the ethane, two carbon like this are connected with the single bond, and 6 hydrogen atoms are makes a covalent bond with the carbon atom, right? So if you consider the molecular formula of ethane, right, that is the C2H6, but instead of one hydrogen atom, if the chlorine atom is makes a covalent bond like this, if the here the chlorine atom is connected chlorine atom makes a covalent bond with this, right? CH3, CH2 and Cl, right? Molecular formula is a CH3, CH2 and Cl. Or we can say that the C2H5Cl, that is the chloroethane, right? So instead of this chlorine, if the bromine atom is, instead of this chlorine, bromine atom is there, we can say that the bromoethane, right? Similarly, chloropropane, bromopropane, you can make a molecular formula of the chloropropane, right? Three carbon atoms and all the hydrogen atom, and from one hydrogen atom replaced by a chlorine or bromine atom, right? So you can make a molecular formula of the chloropropane, bromopropane, right? Chlorobutane, bromobutane, chloropentane, bromopentane, chlorohexane, bromohexane, right? So dear student, you have to make a molecular formula of all the halo group, right? Chloromethane, chloroethane, chloropropane, chlorobutane, chloropentane, chlorohexane. Similarly, you can make a molecular formula of the bromomethane, bromoethane, bromopropane, bromobutane, bromopentane, bromohexane, right? So understand, dear student, halo group, right? Second one is the alcohol. Alcohol ends with the OH. Its name ends with the ol, right? The prefix is a ol, right? For example, the molecular formula of methane is a CH4, right? You know that the molecular formula of the methane is a CH4. The carbon atom makes a single bond with the 4 hydrogen atom, like we are talking about the CH3OH, that is a methanol, right? So here we consider that carbon atom makes a covalent bond with the single covalent bond with the 4 hydrogen atom, right? And the molecular formula is a CH4. So see this. So from this methane, if this hydrogen is replaced by a OH, right? So here the hydrogen is replaced by a OH. The molecular formula is a, this hydrogen is replaced by a OH, right? That is the molecular formula is CH3OH. Single carbon, that is the methane, and OH functional group is there, that is the methanol. So the name of the CH3OH, single carbon, that means the methane, and the functional group is the OH that ends with the ol, that is the name of this CH3OH is a methanol. Similarly, two carbons C2H5OH, that is the ethanol. C2H6 is the ethane, but one hydrogen is replaced by a functional group OH, that is the C2H5OH, that is the ethanol. Similarly, C3H8, right, is a propane, right? C3H8 is a propane, but one hydrogen is replaced by a functional group OH, that is the C3H7OH, that is the propanol. So you can make a molecular formula of the methanol, ethanol, propanol, butanol, pentanol and hexanol, right? Understand, yes student, how to make a molecular formula of the all the functional group. So functional group alcohol, understand, right? Next functional group is the aldehyde. Aldehyde ends with the CHO. In the CHO, carbon and oxygen are, makes a double bond between the carbon atom and oxygen atom, and the carbon atom is also connected with the hydrogen atom with the single covalent bond, and its name ends with the I, right? That means if the one carbon atom is connected with the double bond with the oxygen atom, and other two valency of the carbon atom is fulfilled by a hydrogen atom, like this structure of this, like a carbon atom, between the carbon atom and the oxygen atom there is a double bond, and other two valency is fulfilled by a hydrogen atom, right? H. So here this CHO is a functional group aldehyde. This CHO is a functional group aldehyde, and one carbon atom, that is the name, start with the methane, and here the prefix is a R. So this one carbon atom, that is the methanol. Similarly, if we considering the two carbon atoms, and any of the carbon atom is connected with the oxygen atom with a double covalent bond, that is the ethanol, like this. Like this, here the two carbon atoms are connected with the single bond, and any one of these carbon atom are connected with the oxygen atom with the double bond, and other valency of the carbon atom is fulfilled by a hydrogen atoms, right? So here this first carbon atom is makes a covalent bond with the oxygen atom, and a single covalent bond between the hydrogen atom. So here we put a hydrogen atom. So this is the functional group of the CHO. First carbon atom makes a single covalent bond between a three hydrogen atom, right? So here we put a hydrogen, hydrogen, and hydrogen. So this name with the molecular formula is the CH3CHO. This CHO group is for the aldehyde group, right? And the molecular formula is a CH3CHO. So here two carbon is there. So the name is for the two carbon ethane, and from the ethane the name is the ethanol. Similarly, if you take a 3 carbon, it is a propanol. If you take a 4 carbon, it is a butanol. If you take a 5 carbon, it is a pentanol, and if you take a 6 carbon, it is a hexanol. So dear student, understand this group is called the aldehyde group, and the aldehyde group name ends with the al, right? So if the single carbon atom is there, it is a methanol. If the two carbon atom is there, right, it is a ethanol, right? If there is a 3 carbon atom, it makes a aldehyde group, it is a propanol. If you take a 4 carbon atoms, right, that is a butanol. 5 carbon atom is there, it is a pentanol. 6 carbon atom is there, it is a hexanol. So try to prepare this all the functional group by yourself, right? So here dear student, next functional group is a carboxylic acid. The carboxylic acid ends with the C double O H, right? The name ends with the C double OH. In this, the carbon atom is makes a double covalent bond with the oxygen atom, and carbon atom is also connected with the OH atom, right? OH atom, oxygen and hydrogen atom. So OH group is from the alcohol group, and H group is from the C double bond O group is from the aldehyde group, right? So its a molecular formula, or its a name ends with the oic acid. If there is only one carbon atom, it is a methanoic acid. Let us see the structure. Methanoic acid, right? So here in the methanoic acid there is only one carbon atom, right? So draw a only one carbon atom C, right? This carbon atom is makes a covalent bond with the OH. This carbon atom is makes a double covalent bond with the oxygen. So that is a C double bond COOH, right? Carboxylic acid. Now other three valency of the carbon atom is fulfilled, and other valency, fourth valency of the carbon atom is fulfilled by a hydrogen. So its a molecular name is a HC double bond OH, right? HCOOH. Single carbon is that it is named with the methane. From the methane, it is a methanoic acid, like this, right? HC double bond COOH, that is the methanoic acid. Similarly, you can make a molecular formula from the ethanoic acid, right? So in the ethanoic acid, two carbon atoms are there, right? So if you consider the two carbon atom, first carbon atom and a second carbon atom, any one of the carbon atom makes a carboxylic acid group, right? So this carbon atom makes a covalent bond with the OH atom. OH makes a double bond with the oxygen atom, right? So it fulfills the all these carbon atom fulfill all the valency, right? But this carbon atom makes a single covalent bond with the three hydrogen atom. So we place here H, H and H. So its the molecular formula is a CH3 C double bond OH. So here the two carbon atom is there, and two carbon atom ethane. From ethane, that name is called the ethanoic acid. So if you take a three carbon atoms, it's a propanoic acid. If you take a four carbon atoms, it is a butanoic acid. If you take a five carbon atoms, it is a pentanoic acid, right? It is a, if you take a 6 carbon atom, it is a hexanoic acid, right? Understand? Yes. Let us make a structure of the propanoic acid. So in the propanoic acid, 3 carbon atoms, and any of the carbon atoms at the end makes a carboxylic group, right? So if you consider this carbon atom, it makes a carboxylic group. If you can take this carbon atom also to make a carboxylic group. So if you take this carboxylic group, the carbon atom is makes a covalent bond with the oxygen. This carbon atom makes a double covalent bond with the oxygen, right? And this carbon atom is connected with the two hydrogen atom, right? First carbon atom connected with the three hydrogen atom makes a covalent bond with the three hydrogen atom, right? So place here H H H. So CH3 CHH CH2 and C double bond O COOH. That is the propanoic acid, right? So understand, you can draw the structure of all the carboxylic acid group, right? Propanoic acid. Similarly, you can draw a butanoic acid. Similarly, you can draw a pentanoic acid. Similarly, you can draw a hexanoic acid. So understand how we can form the carboxylic acid group, right? Now last group is a ketone group. Ketone group ends with the C double bond O, right? The carbon atom is makes a double covalent bond with the oxygen atom, right? The group, functional group is called the ketone group. The name of the ketone group ends with the one, right? ONE, propanone, butanone, right? Like this, right? Let us see the structure of the propanone. In the propanone, three carbon atoms are there, right? So here, draw a three carbon atoms, right? One carbon atom, it makes a double covalent bond with the oxygen atom, right? Here other carbon atom makes a single covalent bond with the hydrogen atom, right? So here the name molecular formula is C, this carbon atom C connected with the single bond with the 3 hydrogen atom, right? So CH3, CO, CH3. Here 3 carbon atom is there. So its name is the CH3, CO, CH3, that is the propanone, right? Similarly, if you take a 4 carbon atom, it is a butanone, right? You can draw the structure of the butanone, pentanone, hexanone also, right? So dear student, understand all the function group and how we can make the molecular formula or structural formula of all the hydrocarbons in all the functional group. Halide group, halo group, alcohol group, aldehyde group, carboxylic group and ketone group, right? So now next let us revise the homologous series. What do you mean by the homologous series? The homologous series is a group of the carbon compounds having a similar structure, having a similar chemical properties and whose successive members differ by the CH2 group. For example, alkane, alkene and alkyne. Here the group of the chemical formula group, the carbon compound having a similar structure in the alkane, the carbon compound having a similar structure in the alkene, and the carbon compound having a similar structure in the all the alkynes, right? So homologous series is a group of the carbon compounds having a similar structure, similar chemical properties, and the successive numbers differ from the CH2 group. Here the three group homologous series are alkene, alkene and alkyne. Alkane, alkene and alkyne. So first we know that alkane, right? Alkane have a general formula CnH2n plus 2, right? If you take a n is equal to 1, 2, 3, 4, 5, right? We get the different molecular formula of the different alkenes, right? Suppose here if you take a Cn equal to 1, right? C1, that is the CH4, right? CH4, it names with the N, that is the methane, CH4. If you take a N equal to 2, C2H6, right? That is the ethane, right? If you take a N equal to 3, C3H8, that is the propane. You know that. We already discussed this all the alkane, alkene and alkyne. But here the alkene, all the alkane have a similar structure, all the alkene have a similar chemical property, right? So we are taking in the homologous series, right? So the molecular general formula of the alkene is a CnH2n plus 2, right? If you place n equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, different alkanes use that, and the alkene name ends with the ane, like one carbon is there methane, second 2 carbon is there ethane, 3 carbon propane, 4 carbon butane, 5 carbon pentane, 6 carbon hexane, right? You know that. And structural formula, similar structural formula, right? Methane, you know the structural formula of the methane, ethane and propane, right? So this group is called the alkene group, right? So these groups are consist in the homologous series. Second group is a alkene. Alkene have a general formula CnH2n, right? Their name ends with the in, right? The members are as follow. Like if you take a n equal to 1, right? If you take a n equal to 2, C2H4, that is the ethene. N equal to 3, C3H6, that is the propene. If you take a n equal to 4, C4H8, that is the butene. If you take a n equal to 5, C5H10, that is the pentene. Similarly hexene, right? In the alkene there will be a double covalent bond between the any two carbon atom, right? So structural formula of the ethene, propane, butane, you know that, right? You can draw the structural formula of the all the alkenes, right? Understand? And third one is the alkyne. Alkyne have a general molecular formula CnH2n minus 2, where n starts from the 2. In the alkene and the alkyne, n starts from the 2, right? Their names end with the "-ine", and the members are as follows: ethyl, propyl, propine, butane, hexane, right? That all the things, right? If you take n equal to 2, we get the C2H2. That is the molecular formula of the ethyl. If you take the n equal to 3, C3H4, that is the propine. And if you take a n equal to 4, that is the butane, n equal to 5, that is the pentane, right? And you can easily draw the structural formula of the ethane, C2H2, right? In the alkyne, there will be a triple bond between the any two carbon atom. The functional group lies in the alkyne, right? So here we consider the carbon atoms are makes a triple covalent bond, and other valency of the carbon atom fulfill with the hydrogen atom, right? So here the C2H2, that is the ethane, C3H4, that is the propine, and C3H4, that is the propine, C4H6, that is the butane, right? So you can draw the structure easily, right? We were discussed earlier also this type of the alkane, alkene, and alkyne, right? So understand, dear student, all the functional group and the homologous series, right?